screens and make you presenter. And Melissa, if you wouldn't mind starting the recording, that would be great.
Cool.
All right.
Okay.
Yep, I can see your slide deck.
All right. Now, sorry.
Yeah.
Cool. I hope I'm showing the right screen.
You
so
are.
You should only see the fantastic. Cool. There's still 2 minutes to go. Should we wait a little bit?
Oh, sure. I'm sorry, you guys. I apologize. My my computer clock says 11 o'clock. Clearly, it is in a rush for some reason.
Oh, no worries. Well, my computer clock says 5 p.m., so I think it's a nicer time of the day, I have to admit.
Mine says 11 a.m. It's always fast, and I keep adjusting it. I'm not really sure. Oh, you know what? I just got a new computer, so perhaps I got to readjust this one too. I'm known as a Black Widow around Pragmatic Works because I have broken about 6 computers thus far. I'm in marketing, so I'm not tech savvy.
Okay.
As always, everyone, this session is being recorded and it will be made available on our website by the end of the week. So if you missed any part of it, please do check back under past webinars by Friday and you should be able to see the entire session again.
Cool. So I'm going to be recorded for all prosperity. Marvelous.
We just have you on a constant loop all day, every day.
Oh, no. Cool. Shall we get underway?
Go ahead.
Great. Cool. Good morning, ladies and gentlemen. Actually, good afternoon if you're in my time zone. But yeah, my name's Andrew Thornton-Smith. I work for Pragmatic Works, South Africa. I am a senior SharePoint consultant, and basically what I hope to present for you today is a couple of useful facts, features, information, and tidbits around SQL stuff specific for SharePoint. So basically this presentation is going to be to try and cover the gap for planning and awareness for SQL-orientated resources. We've been told by business, you know, like, oh, by the way, we're going to be setting up SharePoint and it's going to be hosted on your SQL environment. And you know, all the back end is going to be your responsibility. So we're going to be covering some aspects of SharePoint. Just to mention a couple is, you know, some resource-intensive service applications, what to watch out for, database, storage usage, big amounts of SQL I/O or a CPU hog on the SQL side. Also some high-level search considerations. We'll also cover some database placement and some useful information around placement of databases for best amount of speed that you can get out of the back-end environment. Also, I'd like to touch on maintenance plans and also some SQL farm recommendations. Cool. So this is an hour session, and also have some time at the end for some questions. So hopefully we can get into the relevant or the right amount of detail, and yeah, cool. SharePoint. What is SharePoint? Very, very briefly. Microsoft SharePoint is a web application platform that was developed by Microsoft, obviously. It's designed as a central platform for common enterprise web requirements. SharePoint has a multi-purpose design that allows for management, scaling, provisioning of broad, broad variety of business applications. It kind of more commonly is used for internet portals, extranets, websites, also used for document and file management. And sorry, I thought I disconnected. Collaborative spaces, social tools, enterprise search, and also for hosting business intelligence applications. In 2008, the Gartner Group put SharePoint as leaders in the quadrants of its 3 magic quadrants for search, portals, and enterprise content management. SharePoint also happens to be used by approximately 78% of the Fortune 500 companies. And also between 2006 and 2011, Microsoft has sold over 36.5 million user licenses. So that's fairly impressive, and it just goes to show that it is actually quite a popular platform. Cool. Things we're going to be covering pretty much why. Why do we need to know how to set up SQL in a specific way or have things set up in a specific manner for SharePoint? Certain things to consider when we are setting up the SQL farm. We will go over some storage requirements, some farm considerations specifically around storage, placement of databases, etc. We will also, as I mentioned before, cover stuff on SharePoint resource-intensive tasks, service applications to watch out for, databases to keep an eye out on, and search. Finally, some maintenance plans that I normally recommend to be set up on all your SharePoint and SQL farms. If we have time, I've also got another slide which has a bit of information on database sizings, but we will see how we move along. Why is the SQL Server performance important to SharePoint? Pretty much all the information is stored on SQL. Yes, fine, there is a fair amount of information that is also stored on the web front end or the application servers, such as the search indexes, but pretty much the bulk of the information is stored on SQL. So the SQL Server performance is I suppose you could say it's the lifeblood of SharePoint. And frequently, a lot of companies, they don't specify they don't spec the servers properly. If the farm, for example, if your farm is at capacity, disk IO, RAM, network usage is at capacity, certain normal tasks are going to take a lot longer to do, such as running your backups, etc. You wouldn't want, for example, your backups to run over the allocated time into production times. Yeah. Cool. Things to consider when setting up your SQL farm. So basically, in this diagram, I have put a fairly generic setup of SharePoint, so you can have your number of web front-end servers, any sort of number depending on the size of your farm. You also can have your application servers as well, all of which need to connect to SQL. So, without getting into too much detail, I put SQL as the big gray blob. So basically, the stuff to need to be aware of for your SQL configuration is RAM. We obviously need to have a lot of RAM. SQL will take up as much memory as it needs and as much memory as you're able to give it. Obviously, there are settings you can enter for that. Also, the CPU, we also need to be aware of the local disk config. The second thing to be aware of is the HBA settings. So it would be your host bus adapters. There are a number of two that potentially could be used, and they all offer different pros and cons and speeds. Most common is a fiber. You connect to a fiber backbone. You're also able to use SCSI and also combined network, depending on how fancy the environment you guys are lucky to have. The third thing to keep in mind is your disk array connectivity. So this will be how you are connecting to each LUN. A LUN is your logical unit number, which is referring to a SAN, to your storage area network. And it also is related to the type of your HBA, your host bus adapter that you have. The fourth item we also need to be aware of is your disk configuration. Obviously, the more spindles that we have, the greater the I/O that that particular LUN will be able to provide. So the more spindles, the better performance, because we are spreading the IOPS around over the spindles. You also want to make sure that the SAN can respond to your both read and write requests within normally about 20 milliseconds. Ideally, a lot of people recommend ideally you should have around 10 milliseconds. It's also better to have a combination of smaller, faster disks and more of them running together as part of your LUN, as opposed to fewer larger disks, because you are spreading. There's less drives for the read writes to be spread over. Also, something to be aware of is using what type of RAID you select, whether you're going to be using RAID 10 or RAID 5. Basically, the benefits of using RAID 10, it's considerably faster. It's roughly around 4 times faster at reading and approximately twice as fast for writes. Yet again, it does depend on the environment that you have set up. The fifth thing to consider is database placement. Where should we put these databases? Obviously, you don't want to go and put all your databases sitting in a single LUN. So by putting the databases on separate LUNs, it allows for more concurrent connections. Each logical drive, has a number of connections that it can have. It's that you can't have an infinite number of connections to any given resource. There will be a bottleneck at some point. So by splitting these items out, so your TempDB log, transactional logs, content databases, etc., by splitting them out over multiple LUNs, we are spreading the load far more evenly over the environment. Also, I've got to put in backups there, and I've popped it in as a different color. If, for instance, you don't happen to have a backup program that does online backups, so you have a backup program that connects to SQL directly, and it reads the data out of the databases directly live from SQL. That's one option. If you don't have an online backup program, you would have a SQL maintenance plan that will go and run depending on your requirements. We'll touch on maintenance plans a bit later. It will go and write the backups to preferably a non-production LUN. So basically, if, for instance, for whatever reason, your the backups to your offsite backups fail. We once had a client with the robotic tape drive machine jammed, and by the time they fixed it, it already was in business hours. And then they started pulling all the backups, and one of the environments that one of my colleagues was managing, they had their database backups on the same drive as the actual databases. And when the tape drive people were pulling the backups off, their environment slowed down quite considerably. So definitely an idea to separate them as far as possible. Something else also to consider with regards to placement of drives is most people have storage tiers, so we could have online storage and near online storage. Obviously, the online storage is considerably faster, and also it has a higher disk cost as compared to the near online storage. So you can split up your drives based on priority onto slightly slower storage as necessary. Finally, the other thing is if you are using if you have implemented blob storage on your environment, also just something to be aware of, the type of drives and storage that you are storing your blobs on will also impact SharePoint, or the performance for SharePoint. Cool. Hardware requirements. Fairly generic. Basically, we have for small deployments, they will be recommended of at least 4 cores, 64-bit obviously, and 8 cores for a medium deployment. As far as memory goes, for small deployments, they recommend 8 gigs, 16 gigs for medium deployments. As far as local hard drive storage, pretty much since all your databases will be stored, or it's recommended to be stored on your SAN, you only really need local storage for your Windows installation. As far as for memory, if for instance you need to know whether your SQL Server has enough RAM, there's a couple of counters that you are able to watch. The SQL Server Buffer Manager and the Page Life Expectancy. This will tell you how long the buffer expects it can keep a cached page in memory. So you ideally would like this number roughly around 300 seconds or better. If it isn't, the server's performance will be taking a bit of a hit, because essentially SQL is having to access the disks to get the information as opposed to keeping it out of, pulling it out of RAM. With regards to the size of the deployments, if for instance we can take roughly, it's kind of a best guesstimate, but if you take the size of your content databases, so if we have, minimum for a multi-server farm would be 16 gig. If, for instance, our content databases are potentially up to 2 terabytes, they recommend at minimum 32 gig of RAM. If your content databases are up to from 2 terabytes to 5 terabytes, they recommend 64 gig of RAM. 5 terabytes up to 10 terabytes, they recommend up to 129 gig of RAM. However, these are recommendations. Cool. Something else, a little bit of an offshoot for as far as setting up hardware. It's definitely beneficial to have a QA environment. If you're able to have a QA environment, it really is beneficial that you can test stuff there. If one of your customizations, you try something different and you happen to kill the environment, you've killed your QA environment and not production. So it's definitely nice if we're able to do that. SQL Server settings. Cool. Obviously, we need to set the max RAM. Normally, once you've set up SQL, it will go and try use the maximum amount of memory that you have. There is a formula that you are able to use to calculate the amount of RAM you can give. It's a little complex. If you guys would like it, I can provide it afterwards. Pretty much it goes, it takes the number of SQL threads, your thread stack size, etc., and we're able to work out how much memory we should have available for SQL to use. Setting of your fill factor. Set the fill factor to 70 and fine-tune it from there. Basically, it depends on your environment, how the platform is set up, and specifics to the environment. Not every environment is the same. Pretty much the fill factor is provided for fine-tuning the index data storage and performance. When an index is created or rebuilt, the fill factor determines the percentage of space that on each leaf level page that will be filled with data, and reserving the remainder as free for future growth. SQL Server connection aliases. It's fairly useful. It's nice to have. If, for instance, for whatever the reason is, you have to replace your SQL Server, an upgrade, your server hardware is reaching end of life, and you have to go and make a change. If you have a alias set up, all you would really need to do is back up all your databases, restore it to a new SQL instance, set up all the permissions as necessary, power down the old SQL instance, power up the new SQL instance, change the DNS entry, so to say this alias now points to the SQL server, turn SharePoint on, and it's considerably easier than the alternative. Finally, is to plan the storage as effectively as possible. Pretty much, yet again, it depends on, well, to quote a saying, is how long is a piece of string. It depends on your environment. If you guys are planning seriously big SharePoint environments, it would be, try split as much of the resources out as possible, split all the high-end databases onto specific LUNs, etc., etc. And try not to share heavily used databases on the same set of spindles as another set of heavily used databases. Try split it out as much as possible. Farm considerations for storage. Recommended database placement over multiple LUNs, like I have mentioned before. There are a couple of storage requirements that I would recommend. To have a separate LUN for your data drive, we'll put all our MDF files, a separate LUN for our logs, a separate LUN for our TempDB, also for your OLAP cubes, and finally for backups, like I mentioned a couple slides above. We will chat about priority of those, which drives require a higher priority in the next slide. Cool. I've already chatted about the backups. All right. Cool. Okay. Identify the priority, fastest to the slowest drives. The TempDB is, as you know, is fairly important. So the TempDB needs to be listed on your, on the fastest drive. We also need to, the next in line would be your database transaction logs, followed by your search database and your data in the log files, and followed by the content database and their log files. The search databases obviously would have, if you instance you are in a very large farm that's specifically engaged for search, you can also give a slightly higher priority to your search databases. In heavily read-orientated portal sites, so the users are permanently hitting the site for gathering information, documentation, etc., we can prioritize the data, the data over the log. So we'd move the data being from 4th position to potentially right up to 2nd position. Also, not to sound like a broken record, the more spindles increases the IOPS. The number of threads and connections to each LUN is not infinite, so if we can spread it over multiple drives, all the better. Also, we must try to keep the temp database and the content databases on a separate LUN, not on a single LUN that has been partitioned into separate drives. It is better, if at all possible, to keep them on completely separate LUNs, not on partitions of the same LUN. There also is a new trend for the temp database. A lot of people now, if there's lots of bucks available, is that they get some seriously high-speed solid-state disks, and they will go and pop those in RAID, and then they will host the temp database on local storage, but it's super fast SSDs in RAID setup, which is actually pretty cool. Basically, try use multiple data files for the content databases and the search databases. Attempt to distribute equally sized data files across separate disks. The whole goal of using file groups is to improve performance of the system, and it is done by providing additional files, which is your MDF files. And these files should be placed on a different set of spindles to see any kind of major performance enhancement. If your SQL server is not IO bound for any specific of the databases, or to IO bound to any of the LUNs, implementing these file groups and splitting them across potentially you won't see any major benefits. However, with that said, it does give you space to grow, because a lot of times SharePoint is deployed as a starter for Department X, and then slowly Department X will load it out into the next department. So by setting it up this way, it gives you a fair amount of space to grow. Place the SharePoint search crawl chatty when it comes to its search databases, when it is doing the crawling, the indexing, and list items, people information, profile information that search is running, and it does store a fair amount of that information, and it does do a lot of reading into the search databases. But in the next 2 slides, we'll go over which service applications to watch out for. Splitting up with the site collections, it's not exactly something that the SQL resource would probably end up doing, but it is definitely beneficial to kind of know about it, so when you happen to be talking to the SharePoint admin, you can say, what about this? With regards to the site collections, the way how SharePoint works, you're able to have multiple site collections sitting in a content database. So obviously, from the one side of it, you could have, let's just say you have 30 site collections, instead of having, sometimes some companies will go and put all those site collections in a single database, and then obviously each site collection grows dependent on their use. Alternatively, it is better in the long term to split out the site collections, especially the larger sites, to have their own dedicated content database. It has a number of benefits. Just to rattle off a couple of them. If, for instance, there's some sort of an issue and you have to do a recovery for a specific site, somebody realized, actually we've misplaced a whole document library and nobody's noticed it for the last month or something like that. You only have to take that one single SharePoint content database, and then you have a smaller database to work from. You can either attach it to a QA farm to take the data out, or you can do an unattached restore. Okay. All right. Also, just if you have to do a recovery, it's also the smaller number of databases, that each having a smaller size. Your time to recovery is also increased. If you have to recover just a 100 gig database, it's better than recovering a 800 gig database, for example. All right. As far as sizing goes, there's undersizing and oversizing. Obviously, if you happen to undersize your farm, yes, your farm will be able to answer, the requirements that you need it, but it might take a little bit of extra time, because it will be potentially, if it's been undersized, the CPU, RAM, and drive usage will be pretty much at its maximum. However, if you oversize your farm, obviously there's cost considerations. So if you oversize your farm, the farm will be able to answer out your requirements using a far lower level of resources, and it also gives you a fair amount of space to grow in. All right, on to resource-intensive tasks. Excuse me. So pretty much from a SQL perspective, we're going to be looking at the far right-hand side of the table. This goes and lists the SharePoint service applications. Just to explain the X's, it's fairly self-explanatory, but the single X indicates minimal or insignificant cost. The service can share this resource with other services with no impact. The double X indicates a medium cost to the resource. The service can share resources with other services that have minimal impact. With regards to the triple X, it indicates a high resource cost. The service should generally not share this resource with other services. So pretty much SharePoint Foundation Service, that is core of SharePoint. So it's mediocre on the CPU usage. I think we'll just focus on the triple X markers. With regards to the SQL Server IOPS, pretty much as I mentioned before, SharePoint stores everything in all the content, etc., inside the content database. So whenever you request a page, you request a document, an image, you're searching for a list, that information invariably is stored inside the content database. So it's going to be fairly high on your IOPS. Also, your storage. The reason why I didn't mark it in red was because it pretty much depends on the usage of the farm. If you don't store a lot of information on SharePoint, you potentially won't, your databases won't take up a huge amount of space. However, it just depends on your usage. The next one to have a look at is the logging service. The logging service has a quite high on the IOPS and the SQL and the storage. Okay. The logging service records usage and health indicators for monitoring purposes. This is fairly write-intensive service and can require large disk space depending on the number of number of indicators and the frequency at which they are logged. All of this is set up inside central administration. The next one to keep an eye out for is the SharePoint Search Service. This is it's a heavy service that runs. It uses up a lot of CPU, disk input-output, and also on storage. The SharePoint Search Service application provides indexing and querying capabilities. Generally, this is a relatively resource-intensive service, but it can scale to very large content deployments. The next one that we should have a look out for is the User Profile Service. The User Profile Service application is it's a service that powers the social connectivity scenarios in SharePoint. It enables the My Sites, tagging, notes, profile synchronization with directories, and also other social capabilities. The Profile Service requires 3 relatively resource-intensive databases, namely the Synchronization Database, the Profile Database, and the Social Tagging Database. Cool. The next one to also keep an eye out for is the Web Analytics Service. As you can see, it is high across all 3 of the areas we are looking at. The Web Analytics Service application is the service that aggregates and stores statistics on the usage characteristics of the farm. The service has a relatively high SQL Server resource and storage demands. In large SharePoint deployments, it's recommended that we isolate the web analytics databases from other important resource-intensive databases by hosting them potentially on different LUNs, different database servers, potentially at the far end. Cool. Also, the other services there, they are fairly lightweight, which we don't have to worry about them too much. Continuing on, moving on to the project service. Project Service application. This is the service that enables Microsoft Project Server planning and tracking capabilities in addition to SharePoint 2010. This service requires the application server and a relatively resource-intensive database. In large SharePoint Server deployments, this is a frequently used capability. We should dedicate a database server for project service. That's only in really
Hello, Andrew. We've lost you. We're getting some static. Can anyone else hear Andrew or I?
Hey, Rachel, I can hear you.
Okay, so we've lost Andrew temporarily for a second. If everyone can please bear with us, we're going to try to get him back. Bear with us for one moment.
Rachel, you still there?
Sure.
Oh.
Hi, yes, I see. Can everybody hear me now?
Yes, I can hear you now, Andrew.
Okay, cool, great. Sorry about that. Again.
I think we're going in and out here. I'm not sure if it's you on your side or on our side.
I am
I think Andrew's
connected
dropping
now.
a little bit. Yeah, you're good to go, Andrew. Go ahead.
Great, cool. Sorry about that, guys. Great. Okay, sorry, I don't know where I left off. So Power Pivot. Power Pivot is fairly intensive on the for SQL Server disk usage. The the Power Pivot Service application gives you the ability to enable Excel worksheets to be displayed directly from the browser. In large deployments, and this particular functionality has become a frequently used piece of functionality, it is recommended that we have a sufficient number of application servers and a sufficient amount of RAM and CPU to ensure acceptable performance and throughput. All right. Cool. Search. For large search platforms, like we've mentioned a couple times before, splitting up the search-related databases to a separate SQL instance. This is for really large search environments. Now, when I say large, people are like, well, how large is large? Large platforms are when the content that is going to be searched is potentially in excess of a terabyte in space, and also will have potentially over 30 million items in the index. So this is when we would recommend having a separate SQL instance dedicated for the search databases. Also place the search crawl and query databases onto separate spindles, and also create additional crawl and property databases. The benefits of creating additional index partitions and query components is, firstly, we are splitting the load, but also we are providing redundancy in a multi-server farm. Something else with regards to search, it's not too much on the SQL side, but just some additional information, is when the guys are speccing the SharePoint farm, we should mention that the search, part of search, you get the indexes are stored locally on the SharePoint machines. So obviously the drives that are hosting that particular index also need to be fairly zippy and also have to have a fair amount of space. There's a kind of a general rule of thumb of you need a third, slightly less, the third of the size of the content to be crawled. Other things to consider for search, if, for example, how much we need to farm out our instance, how much we need to split across to different LUNs, etc., is the corpus size. How much content needs to be searchable? What the total number of items? Now, this should include all objects, documentation, lists, web pages, people, all sorts of any sort of information that is stored on SharePoint that is such that is would count to how much is going to be sitting in your index. Content freshness is also a key thing to be aware of. How often does the search need to run in order to get through all the content? So a user, Bob, goes and uploads a document. How long is it until Bob can make a search and find that particular document? Obviously dependent on the size of your items that need to be in the index, the amount of data it has to go through. Potentially we would need to adjust how often the search will run. Also throughput. How many users are going to be searching this content simultaneously? Now this also includes Bob and Jane goes onto their SharePoint site and they go to their search center and they type a search query and they hit the OK button and then it goes and returns results. It also includes hidden queries such as you could have somebody has gone and designed a custom web part. So based on, let's just say, you have a performance point dashboard and you go and click on a specific item and then it will go and return via search, it will return all the documents potentially relating to the client that you selected. So all those items need to be considered as to how often search is going to be used. And then also to consider availability. Cool. Maintenance plans. Basically, in my experience, the clients and stuff that I have been to, you get there and they've got their SharePoint server set up, SQL set up, and you're like, great, can I see how your backups are done? And they look at you blankly, they blink a few times and they don't know. So what I recommend is create some maintenance plans for your backups, dependent on your requirements. You do a full backup potentially once a week, yet again dependent on requirements, and differential backups once a day. Also transactional log backups, dependent on the environment and the criticality of the data. Potentially you can do transactional logs every single hour, and then you can potentially go down to the level, if you have to do recovery, you can do point-in-time recovery. Also, you need to have a maintenance plan to make sure the backups are cleaned up. So you can have a plan that goes and says databases of whatever file extension .back or LDF or not LDF. I forget the TRN file. So it will go and say if it's over a certain date, certain age, to be kicked out. Also, a couple of maintenance plans, integrity checks, history cleanups, rebuilding your index, and also updating your statistics. The reason why I've gone and put a little star next to the bottom two items is SharePoint 2010 has the health analyzer rules. And what happens is these rules, there are a number of rules, there's actually quite a lot of them, that go and monitor the health of your SharePoint farm. They will go and monitor, you've got large amounts of unused space in your databases, etc. But there also are rules that specifically go and do the rebuilding of the index and updating your stats. However, it's not for all the content databases. Just to quickly cover the databases that it does do it for is your content databases, your SharePoint configuration databases, the user profile service app databases, which is only two of them, the profile and social databases. The web analytics, reporting and staging databases are also included in those health checks. And also the word automation services databases are included in the health analyzer rules. However, the other content databases, for instance, for any of your other service applications, are not included. I go and create a maintenance plan that covers all of my databases for rebuilding, indexing, and for the stats, and I have no issues. As far as fragmentation, the content databases and the search databases are the most susceptible to fragmentation. Yet again, dependent on how you guys, how you guys prefer to operate. Rebuild them, rebuild them as often as necessary. Cool. Basically, we've got 20 minutes left, so I'm going to briefly go into the slide that I wasn't sure I'd have enough time for, specifically around database sizing. With regards to site collections, like I mentioned before, you're able to have your site collections. You can have multiple site collections to a content database. You are able to have, it's recommended that for any site collections that are greater than 15 gigs, Microsoft recommends use SQL backups. I personally only really use SQL backups because it's the ones I've had the most success with recoveries. Limit your content databases to 200 gigs. This is a soft limit. It is a best practice limit provided by Microsoft. However, there are times where they are supported scenarios where content databases up to 4 terabytes are supported. However, there are very specific requirements that do need to be met in order for Microsoft to support you. Very, very briefly, your disk subsystem performance needs to be 0.25 IOPS per gigabit per second. Two IOPS per second per gigabyte, sorry, is recommended for optimal performance. And also you have to have a number of other things in place, such as develop plans for high availability, disaster recovery, capacity planning for future growth, etc. With regards to the size of your SQL Server data files, try size them, nicely. Pre-allocate your data file to cover anticipated size of the content database. Yet again, it sometimes can be very difficult to anticipate the growth. However, we wouldn't want SQL to permanently be, okay, my database is full, I need to auto-grow, and then it has to go through the IO of auto-growing, etc. Every, I don't know how often it potentially might happen, dependent on the content that is going into SharePoint. Don't rely on auto-grow. Then use dedicated databases for your large site collections in excess of 50 gigs. Yet again, this is personal preference, dependent on the back-end system that you guys have. It's pretty much have a look and see what suits best for you guys. I do personally recommend having large site collections on their own dedicated database, just in case there are issues. Configure the temp database to be at least 10%, 25% growth of the total content database size. Yet again, personal preference. Pretty much that is me, and we have got about 15 minutes for questions if you guys have any.
Yes, we do have several questions. The first one is, do you know what the recommended, I'm so sorry, I'm going to spell this out, MAXDOPS, MaxDOPS, is for SharePoint?
Not offhand. Very quickly. I can definitely get back to that use. I don't know straight offhand.
Okay, that's definitely something we can follow up on, and I'll pass this webinar report along to you, Andrew, which will include the questions. And our next one is from Carrie. She was told by a Microsoft DSE that SharePoint databases could not be reorganized and rebuilt as we would have any other database because it was a different kind of animal. What does this mean?
Sorry, just to recap the question, that someone told them that they can't do like a reorganizing the index, etc., as compared to like you would with any normal database.
Right.
I haven't come across that. Like I said, I have my maintenance plans, and I set them up at all of my clients that I'm at, and I have yet to have any sort of issues, any sort of errors with regards to reorganizing them as I would any other database. They are, like I mentioned, some of the the health analyzer rules do touch on some of the databases, but they don't cover on don't cover them all. So potentially, whoever was recommending this might have been slightly confused about maybe one of the health analyzer rules specifically deal with that, but I haven't come across that at all. So no issues from my side.
Good news. Mary would like to know, can you repeat the IOPS needed? She didn't catch it. She thinks you might have said 2 per second, but she's not sure.
Let me just minimize the window I'm on. Sorry. The IOPS per second, based on the research that I was doing when I was preparing this, they say the disk performance of 2 IOPS per gigabit, sorry, 2 IOPS per second per gigabit is recommended for optimal performance.
Okay, great. Another question is, can we
I can also give the resources if necessary, if they would like to go and have a look at the Microsoft site. I can also provide that later, but you can give me the details later if necessary.
Absolutely.
Cool.
Another question we have is, can we schedule SQL transactional backups and SharePoint console backups at the same time?
Me personally, no, I wouldn't do that. Basically, if you're running a console backup, so I'm assuming you mean console backup, that would be you running a PowerShell script, backup SP sites or export sites or whatnot. I guess you could, but the potential for locks potentially could be fairly high, and also it's going to really hit your SQL server fairly hard, because you're going to have 2 sets of backups potentially running at the same time. So I wouldn't really recommend that. I'm not quite sure why they'd want to run both of them at the same time.
Okay, great. George would like to know, if you delete content from SharePoint, how do you reduce the size of the content database?
Cool. There are a number of things just to be aware of about that. So let's just say, for example, I have a document library, and I happen to have, for whatever reason, duplicate data, and it's a fair amount, and I go and delete that. Obviously, if you go and delete that, it's not going to appear immediately. What happens is it goes from the deleted, it gets deleted, and it goes to a site-level recycle bin. That is the recycle bin that the end user is able to go and access. So what's going to happen is that would need to be emptied. You can do that from the site action site settings on your site. Also, once it has been deleted from the site recycle bin, it then gets moved to a site collection recycle bin, which pretty much is the administrator's recycle bin, which that will then go and sit for basically there's a number of rules that are set for the recycle bin. So it will say either it reaches a certain amount of space or it reaches a certain age, and then the rules automatically will then go and delete it. But if you can't wait for those rules to kick off, delete it from the first level recycle bin and then go and delete it from the second level recycle bin. You can do this all from these site settings pages.
Okay, wonderful. KT would like to know, can you speak to the advantages and disadvantages to virtualizing the SQL layer in SharePoint?
Cool. Virtualizing SQL layer is a bit of a hot potato. Some people say it's okay. Other people will absolutely flat out reject any sort of offer to, like you say, oh, what about virtualizing? And they're like, not a chance. A couple of the reasons behind this is the following. First of all, if, for instance, you go and have, I don't know, VMware, Hyper-V, whichever technology that the guys happen to be using, if you go and specify that the amount of RAM that can be given to a specific VM is flexible. So if the VM needs additional memory, the VM host will go and provide additional memory to to the guest VM. Now, if, for instance, this VM happens to be SQL and it happens to be being hit fairly hard, SQL obviously is going to require, you're going to say, oh, I need more RAM, and the virtual host will say, yeah, it's great, of course, here's more RAM, it will give you more RAM. Now, if it keeps taking more and more RAM, if the virtual hosts have the opportunity, the VMware call it virtual motion or something like that. Basically, what it will do is it will take the less used VMs off that host onto other hosts to allow that single host to process that one machine that's that's got heavy resource requirements. Now the problem is, if you allow this to continue, what's going to happen is you're going to have a one-to-one relationship. You're going to have one server, one virtual machine onto one virtual host. The whole idea of virtualizing stuff is to share the physical tin with multiple machines. So I guess that's kind of where it comes from. As far as performance goes, I guess it depends on the back end. If your virtual machine host is using high-speed SAN drives, the performance is not bad, but it just depends. It depends on the environment. But a lot of people prefer not to virtualize SQL.
Okay, wonderful. Peter would like to know, is there any way to prevent SharePoint from creating .mdf and .ldf data files on the same drive?
Yes, basically it's fairly quick and easy to do that. Okay, well, there are a couple of things to consider first. If you go and set up on SQL before you've gone and created your SharePoint databases. So on SQL, you go on your SQL instance, right-click, Properties, and then you go and view, I think it's called, I can't remember offhand, it says file locations or something. You can specify that the LDF files, the log files, will be created on drive G, whatever, and then the MDF files, the data files, could be created on drive L, for example. Then when you go and create any database, whether it be from the SQL console by scripts or by the SharePoint UI, you would be able to just say, create new database, and then it just goes to SQL and says, I need to create a database. These are the specifications, and then based on the settings inside SQL, it will go and say, right, the LDF goes to this location, MDF goes to that location, and that is how we're able to split it. If, however, the databases already exist and they all are on the same database drive, then what would probably be best to do, organize a bit of downtime. There are a number of ways to do this, but I think probably the simplest would be organize some downtime, stop the SharePoint services, using inside SQL, detach the database, move the LDF and the MDF files to the relevant locations, and then reattach it, and you specify, here's the location of the MDF, here's the location of the LDF, and you attach the database, and you restart the SharePoint services, and Bob's your uncle.
Okay. Peter's saying that he's tried that, but SharePoint overrides it. Is there any workarounds for that?
I've never come across an instance when SharePoint would override it. It's specifically a setting inside SQL. Just very quickly, I'm just going to remote connect into my server, and I will very quickly show. Helps if I get the password right. come on. Caps. All right. Can you guys see my SQL instance on the screen? There we go. Okie dokie. So basically, right-click on your SQL Server instance, go down to Properties, and then we are looking for Database Settings. This is the only place that I know of that you are able to specify the location. So since this is my virtual machine, I only have a single drive. It is going to drive C, and you can quite easily go and change that to whatever drive, dependent on whatever number of drives you have. Okay. But like I said, this is only for newly created databases. You make this change, you have to restart the SQL service, and then it is only affected for new databases. If the database already exists, you're going to have to go and move it, like I described a short while ago.
We're also getting several suggestions from our audience that it might be an issue with the model, with it being set to model database as a default. So.
Just trying to think. Yeah.
We can move on. Another question is there a primer available on using SQL Server 2008 R2 with SharePoint?
A primer, kind of like a getting started, things to know type thing.
Right.
I don't think, I think it would be very difficult to go and say, yes, no, there's one resource you must go and read and it will tell you everything. I think the one resource that is definitely invariable would definitely be Google, TechNet, and there are a lot of SQL blogs and stuff out there that would definitely be able to give little tidbits about, oh, some site would recommend, we recommend this, we recommend that. But it's very difficult to go and say, you know, oh, there's one document to go and have a look at. So it's not something I can go and say, oh, just go to this web address. But definitely TechNet and search for SQL blogs. That would definitely be the first place I would recommend going to look for.
Okay, great. Another question is how do you split site collections to different databases on the existing environment?
Yeah, that is a bit of a tough one. There are a number of ways that we can go around in doing that. Basically, I definitely recommend there's going to be some downtime. I would go and use PowerShell to do a site collection backup, and that will go and back it up, you know, be like the console backup that one of the other guys were talking about earlier. Go and do PowerShell to make a backup of that. It writes it to the file system, and then you would go and create a new content database. And then in your PowerShell script, when you are restoring that site collection, you would then go and specify, you know, the /database name, and you specify the database name, and it will import that site collection into the into that database. The nice thing with it being a site collection, the URL won't change.
Okay, great. Do you have a recommendation for max degree of parallelism? Should it remain 0?
I didn't actually touch too much on that, so I can't answer that straight off the cuff right now. Perhaps we could come back to that one if you don't mind.
Absolutely. And we have another question. Can you please repost the URL for the Microsoft site with the IO requirements?
Not a problem. I will. Shall I give it in the chat window, or should I give it to you?
If you can put it in the chat window, that would be perfect.
Let me just get, I'm just trying to find the slide that I wrote it on with the, it's on here. Okay, there's a number of links here. I just want to check that I have the right one.
No problem.
Cool, so in the meantime we can move on to one of the questions while I'm just opening.
Wonderful. Could you clarify the issue with the crawl and property databases?
An issue?
I'm not really sure what you mean, Dimitri. By default, MOSS using file storage for indexes.
Oh, basically the SharePoint search, the stuff isn't all stored on the database. There is a local copy of the index that is stored on the SharePoint server. So basically, if, for instance, there happens to be some sort of failure, I don't know, network or whatnot, and you're only able to get to that one SharePoint server, you could still search existing crawled content. I assume that's what the question is regarded to. It's not particularly clear.
Mm-hmm. And I can answer one of these questions, actually. Yes, this session is being recorded, and it will be available on our website under past webinars by the end of the week. So you can check back under past webinars by Friday. And our last question is from Steve. Could you please give us some specific suggestions for how to deal with search service databases that have a very high I/O?
Specific recommendations for search databases that have a very, very high I/O.
Mm-hmm.
Well, basically, you know, sounding like the broken record, like basically put them onto a separate LUN, because obviously if there's a high I/O for these particular databases, put them on a dedicated LUN. If you're able to specify the number of spindles, so basically have a large number of spindles. Spindles, just in case the guys aren't familiar, spindles is the number of drives in your array. So basically we have a LUN that is presented to us. It is a block of storage. This block of storage could potentially be made up of 2, 3, 10, 15, 20 different drives. The more drives it is spread over, obviously the higher the your I/O will be, so you're less likely to hit a bottleneck if it was on a LUN that is being shared by, for example, your Power Pivot or your user profile or the web analytics service application. Try split it out so it has its own dedicated space. And I think that's
Rachel, you still there?
The organizer has ended the session.